AI agents have a hardware problem. The demos make them look simple. Ask the agent to do a task. It plans, it searches, it calls tools, it reads files, it writes an answer. But under the hood, agents are greedy. They do not ask the model one question, they ask many questions. Classify this, summarize that, choose a tool, parse this output, check if the result worked, try again. That means if your agent uses a huge model for every little step, it becomes slow, expensive, and impossible to run on small devices. That is why LFM 2.5 is interesting. Liquid AI is building models for on-device agentic AI, and the small versions are designed to run in places where normal AI stacks feel ridiculous. The headline is not that a tiny model suddenly beats the biggest cloud models. It does not. The headline is that useful agent pieces are starting to fit in tiny memory budgets, and once an agent can run in a few gigabytes of RAM, the whole AI deployment story changes. So in this video, we are going to look at what LFM 2.5 is, why small agent models matter, what kinds of agent work actually fit in 2.5 gigabytes, and why the future of agents may be less about one giant brain and more about small models doing the right job at the right time. Hey, don't forget to like and subscribe for more like this. Now, back to the video. A lot of people still think an AI agent is just a chatbot with tools. That is partly true, but it misses the important part. An agent is a loop. It receives a goal, it decides what information it needs, it calls a tool, it reads the result, it decides what to do next, it checks whether the task is complete, then it either stops or continues. That loop can be expensive. If every step hits a giant cloud model, the agent may work, but the cost and latency build up fast. And most steps do not need a genius. Choosing between three tools does not always need a frontier model. Extracting a date from a short message does not always need a frontier model. Summarizing a small result does not always need a frontier model. Checking whether a command output says success or failure does not always need a frontier model. That is where small models become powerful, not because they replace every model, because they remove waste. They let you keep the expensive intelligence for the steps that actually need it. That is the agent architecture people are moving toward. Small local models for routine decisions. Bigger local models for harder reasoning. Cloud models only when the task is worth it. LFM 2.5 fits directly into that story. Liquid AI describes LFM 2.5 as a family of on-device models built on its hybrid LFM architecture. The point is efficiency, fast inference, small memory footprint, useful instruction following agentic workflows on real devices. The family includes small text models, retrieval models, encoders, audio language models, and larger mixture of experts models. That matters because agents are not only about writing long answers, sometimes they need retrieval. Sometimes they need classification, sometimes they need tool calling, sometimes they need audio, sometimes they need a small, always-on assistant. The interesting part is the shape of the family. Liquid has models like LFM 2.5 230 million and LFM 2.5 350 million at the tiny end. It has 1.2 billion models for stronger on-device instruction following. It has an 8B mixture of experts model with about 1B active parameters for heavier local work. That range gives developers options. You do not always want one model. You want the smallest model that can reliably do the step. That is how agents become practical on normal hardware. 2.5 gigabytes sounds almost too small for agents, but the important word is not model. It is workflow. An agent running in 2.5 gigabytes is probably not a giant autonomous software engineer. It is not going to replace the best cloud coding system, but it can still do useful agent work. It can route tasks, it can classify input, it can extract structured data. It can decide which tool should run next. It can summarize short results. It can help with local search. It can run as a lightweight assistant inside a browser phone, desktop app, or edge device. That is a practical value. The model does not need to be brilliant at everything. It needs to be cheap enough to call often. Agents need many small decisions. Small models are good candidates for those decisions. This is why memory matters more than people think. If the model only runs on a large GPU, it belongs to a server. If the model fits on a normal laptop, it belongs to a developer. If the model fits in a tiny memory budget, it can live inside apps, devices, and local workflows that never had room for AI before. That is the unlock. The first use case is a local command router. You speak or type a request. The small model decides what kind of task it is. Search, calendar, file lookup, shell command, summary, extraction. Then it hands the work to the right tool. The second use case is structured extraction. Give it a small message, receipt, form, bug report, or log snippet. Ask for clean fields. Date, amount, name, priority, error type. Next action, this is agent fuel. The third use case is local memory. Small embedding and retrieval models can make private search practical. Your notes stay local, your documents stay local, your app can find the relevant information without calling a cloud embedding API every time. That makes local agents much more realistic. The fourth use case is background assistance. A giant model is expensive to keep awake. A small model can sit closer to the device. It can watch for simple triggers. It can summarize short context. It can decide when a bigger model is actually needed. That is a much more sensible architecture than making the biggest model do every tiny job. This is the caveat that makes the whole thing honest. A small model is still a small model. It will not reason like the best frontier systems. It will not handle every ambiguous instruction. It will not be reliable enough for unsupervised high-stakes actions. It may call the wrong tool. It may parse something incorrectly. It may miss context. It may sound more confident than it should. And if you ask it to write a large code base from scratch, you're using the wrong tool. The win is not maximum intelligence. The win is useful intelligence per gigabyte. That is a different benchmark. For local agents, useful intelligence per gigabyte may matter more than raw leaderboard rank. Because an agent you can run everywhere can be more valuable than a smarter one you can only afford to call occasionally. That is especially true when the task is repetitive. If you need to classify 10,000 short inputs, a tiny local model that is good enough might beat a cloud model that is technically better but expensive and slow. If you need an offline assistant on a device, a huge cloud model does not help when there is no connection. If you need privacy, the best remote model may be disqualified before the comparison even starts. LFM 2.5 points at a bigger change in AI agents. The future is probably not one model doing everything, it is model orchestration. Small models close to the user, specialized models for retrieval and classification, vision models for screenshots and camera input, audio models for voice, larger models for hard reasoning, cloud models for the tasks that justify the cost. That is how agent systems become efficient. They stop treating intelligence as one giant call. They start treating it as a stack. This is also why on-device AI matters commercially. If the agent can run locally, the app developer is not paying for every tiny user action. If the model can run offline, the product works in more places. If the data stays on device, the privacy story is stronger. If the small model handles routine work, the expensive model becomes a specialist instead of a default. That is a much more durable architecture. And it is why small models are not boring. They are infrastructure. So should you care about running agents in 2.5 gigabytes of RAM? Yes. If you understand what the claim really means, it does not mean a tiny model becomes a perfect autonomous developer. It does not mean the cloud is dead. It does not mean every task should run on the smallest model possible. It means agent work is being broken into pieces, and some of those pieces are now small enough to run almost anywhere. That is the important part. LFM 2.5 is interesting because it is built for that world, fast, small, on device, useful for agent workflows, not as the one brain to rule them all, as a local worker that makes the whole system cheaper, faster, and more private. This is where AI agents get real for normal devices, not when every phone runs a frontier model. When the phone can run enough intelligence locally to decide what should happen next, that is the practical future. Small models handling small decisions, local memory staying local, bigger models used only when needed, and agents that feel less like cloud demos and more like software that actually belongs on your machine.